In this video, I will start talking about the power supply. So here I'm using a 9-volt voltage source right here, and I use a wire splitter to split into four wires. And the first wire goes to the Arduino to feed the Arduino. So that's 9 volt there. And the second wire goes to the DC to DC converter, the smaller one, the 3 amp rated converter. And then the third one goes to the 8 amp DC to DC step down converter over here. So just plug this in right here. The fourth one is actually free right now, so it can be used for anything really. Alright, so that's pretty much for this part, for 9 volts at least. Okay, and then the 5 volts will go to the XP, the wireless transceiver, right here. And then actually the XP has a like these metal header leads. So you can actually use this to feed the breadboard to power it up. Okay. Alright, what else should I talk about? Okay, one thing about this thing, when you're trying to charge it, you have to turn on flip the on button this needs to be on. And you charge using a 12 volt charger. It goes to the 12 volt thing. Okay. And okay, let's talk about the servos. Let's talk about the breadboard. Okay. So over here you have it's a little messy, but it's all labeled, so it shouldn't be too bad. But I try to keep everything, so I have the 5 volts power rail over here. So let me make sure that's the 5 volts. Yes, that's the 5 volts. And over here is the 6 volt power rail, which is for the servos. All the servos are connected here. Okay, and here are the 2 MOSFETs for stability issues. It helps stabilize the startup, like I talked earlier with the schematic. Okay, and then here we have the smaller MOSFET. But this is the smaller MOSFET, and zoom in. So this is a 2N7000 MOSFET. It's used to short the camera wires. Here we have a breadboard power supply. It's not doing anything right now. I'm just using it so that it's easy to hook up the 5 volts and the ground wires to the male headers they have here. Just remember that the XP is feeding the 5 volts to this power rail right here. So without the XP connecting to the power rail, this circuit wouldn't work. Okay.
Oh, here's the best part. Okay, it's on the subscript.
All right.
So we get take this one. Is the number.
So about these Buzz 101S MOSFETs, the first pin is the gate. The second pin is the drain, and then the third pin over here to the right is the source. And the source is connected. All the sources are connected to ground. This is the drain. Is where. Let's see. So this is how you control the grounds. But if you put the driver's ground, this is the motor driver's ground. I just place it to the drain. So, and then on the source part, I just plug that to the ground of the DC to DC step down converter. So instead of this thing connecting directly to this ground, we're using a MOSFET so that the Arduino can control when it's going to be on and off. Same thing for the servos. In a similar manner, the ground is being controlled by the Arduino. Okay, so here we have the pen and tilt servos. It's really nothing special about it. Just 6 volts powered up to power these servos up, and then the PWM pulse width modulation from the Arduino to drive it on the signal wire. So there's only 3 wires for the servos. Keep that in mind. Okay, and it's being connected to the pen and tilt chassis that we got from eBay. All right. Okay, so this is the camera with the 2 wires I talked about. So all I have to do is just, if you want to manually capture an image, just short these 2 wires. Okay, and something else about this camera, it's the on and off button is not digital. I mean like power on and off. When you want to power it up, you have to actually turn on by flipping the shutter over here, just like that, to turn on. And these use 2 AA batteries over here, open here, and it has an SD card to store the images. Okay, and when you turn on, if you want to save battery, just turn off the flash off. Okay, so now this is ready to go, so the Arduino can actually take a picture. Okay. So this is the 9° of freedom sensor. The red wire is the power, 5-volt power. The black wire is the ground. The green wire is the clock line, or SCL. Yeah, that's clock. And the white wire is the data line, which is the SDA. And this sensor uses I2C, so keep that in mind. There's only one I2C port here on the Arduino, so it's kind of hard to miss on the Arduino. So SDA and SCL over here. Hook up the clock to SCL and hook up the data line to the SDA. Okay. Alright. And over here we have the laser rangefinder from Parallax. It has 4 leads, 1 ground is a black one. We have the red one is the 5 volts for power, and you have the yellow, which is for signal out. This is 0, by the way, so it's UART friendly. And then you have SN for signal going in. And this serial is connected to the serial 1 on the Arduino. So connect the yellow wire to the RX1, and then the white wire to the TX1. Okay. Alright. Let me see what else should I talk about. Alright, let's take a look at the motor driver. This will be a little harder to see, but this side is actually the logic side, and I know it's kind of hard to see, but the red wire is the 5 volt to power up the MOSFET for the logic side, and all the way to the right side you have the ground wires. It's black, and the other 4 are color coded, all defined in the code. So those are the logics to control the on, off, and polarity of the motors. Okay. And to the other side of this robot, if I can turn this around. Okay, on this side This is the power side. So I have the ground with connected to a blue jumper wire, and this is connected to the MOSFET. This is connected to the MOSFET drain. Okay. And all the way to the right, I have a red wire, and this is the power, 7.2 volts to power the DC motors. And this is connected to the DC to DC, AM DC to DC step down converter. The other 4 wires between the positive and negative is the motor wires. Naturally there are 4 because there's 2 DC motors. Two DC motors, okay. Alright, so I think that is basically all for this segment, and in the next segment I'll talk about how to program and then control this robot using the command line. Alright, I thought it would be useful before I move on to the programming part, to go over one more time in detail all the wires connected to the Arduino. Okay, over here I just have an LED that's connected to 2 pins just for debugging. Both the pins are set to output, so I can use one of them for ground, and the other one as a anode. The other one's the cathode. The ground is the cathode, and the other one's anode. And one more thing, if you're not familiar with LEDs, the anode is the round side, and the cathode is the one with the flat end. That's how you can tell without looking at which one's longer, which lead's longer. Okay, and let's look at this wire. I have a ground wire connected to the breadboard. Ground over here for stability issues. It helps. Yeah, it's always helped to connect grounds together. So the closer the grounds, the better they are. Okay, over here, instead of connecting the 9 degree of freedom sensor power 5 volts to the 5-volt rail on the breadboard, I just connect directly to the Arduino. So it's easier to debug without turning on the actual battery. Because when I program this one, you don't have to turn on the power supply. You can keep it off because you can power it off using the USB from your laptop. Okay. So when I power using USB, I can actually access the 9 degree freedom sensor because it's powered through the Arduino. Okay, these are the 2 wires to power up the 9 degree freedom sensor, and this is 5 volts and this is ground. Alright, next in line is the cam switch, which is cam SW, has been tagged here. It is connected to Arduino pin 30 on the back side. Okay, and this is connected to the MOSFET. It's connected to the MOSFET's gate to control this 2N7000 MOSFET. So again, pin 30 for the cam. So the next one is pin 28. This is one of the motor logic wire. Let's see. Well, it's not tagged on the jumper, but it should be labeled in the program which say like yellow would be like control or direction or something. So there are 4 wires because there's going forward, backward for each motor, and then on and off. So there's 4 wires. And then let's see. Okay, let's talk about this wire. This is the motor power controller pin 27, and it goes to the second MOSFET right here. It goes directly to the gate, which is the first pin of the MOSFET. and that controls the grounding of the motor powers. And then the pin number 25 on the Arduino will control the servo power. It controls the grounding of the two servos. So when this is high, then the ground will be connected to ground, the actual ground that would drive the servo. Okay. Okay, I wish I could be more thorough on these 4 wires. So I'll explain these wires later. But just remember, these are to control the direction of the 2 motors and the on-off state of the motors. Okay, so let's go on to these 2 wires. So the black one's obviously ground. This is the 6-volt power rail, and the 6 volt, this is the source, which comes from the DC to DC step-down converter. 6 volts come out and it goes right here to feed off the 2 servos here. You see the 2 red jumpers here are for the servos. And instead of grounding the servos directly on the ground rail, we hook it up to the drain side of the first MOSFET. And then the actual ground is connecting using a black jumper to the source of the first MOSFET. So when the Arduino switch on, the drain and source will be shorted and the ground will be grounded. Okay, so this piece of wire, black piece of wire right here sticking out, is the ground for the camera for this MOSFET. So this is the this side of this MOSFET is the source. So I'm grounding the source with the ground wire, and the blue wire here you see is from the Arduino to control the on-off of this MOSFET. So when it's on, it's going to short these 2 camera wires. So we'll take a picture. Alright, so here is the 5-volt line, and this wire goes to the logic side of the motor driver. It feeds the 5 volts to the motor driver. Okay. Here, these 2 wires are to power up the laser rangefinder. This is the ground, the black one, and the red one is the 5 volts. Okay. Again, these 2 wires comes from the XB. So you must connect this wire to the XB 5 volts so the breadboard will be powered. And okay. Okay. Notice how this long piece of black wire here is connected from the Arduino to the header here, just to short those 2 grounds so they'll have the same ground. The other black wire is from the XB, of course. So these are from the XB. These 2, 5 volts and ground from the XB to this male header on the power, breadboard power supply, which is not going to be used. Oh yeah, one last thing. Make sure you press this button, press down to stay down, so that the output will be connected to the rail. And it's like a switch on off to control the rail. Okay. Okay. Well, I guess I went over all the wires here. and make sure. Okay. So this is the output from the DC-DC step-down converter, the 8 amp one. So the positive will go to the motor driver, power side directly to positive side. However, the ground is being controlled by the MOSFET, as I mentioned earlier. So this ground side of this DC-DC will go to the source side, and then the ground from the motor driver will go to the drain side of the MOSFET. So when the Arduino switch on the gate, turn high, these two wires will be shorted, so it will be the same. So that's all for that part. Okay, let's talk about programming this thing. Before you program anything on this robot, you want to take this USB cable off right here. So that the idea is to turn this thing off, but then you also need to take these two wires off, or else it won't work. Because there's still a little current or little power that power up the XP on those two wires somehow. So you don't want, because when we program, we're using the serial 0 line on the Arduino, which is being shared by the XP also. So you don't want to program to the XP. Okay. So to connect to your laptop, you need a USB cable, USB cable with the A on one side and USB B on another side. So just plug up the USB B to the Arduino side, and then USB A to the laptop side. Alright, so I just connected the USB wires, just this wire to the Arduino and then to my laptop. And I made sure that the USB to the XP is disconnected, and these two black and red jumper wires are disconnected also. So now you go to your laptop and open up the Arduino software program. So just open it up. Alright.
So what's the difference between DCAS and DGOR?
So now let's just open up the program.
What do they do?
DGOR returns computes the value U, which is your is it knots?
Yeah.
So here's the program.
Set the nons.
Oh, it's called a parametric value.
Let me get to a better position.
Parametric value, it's called U. So you know, right.
So notice earlier how I mentioned about how this thing is, all the pins are labeled with, and then a comment in the color of the jumper wire. So it's pretty simple to follow this. See, baby blue, purple, gray, motor controller, direction. So these are the 4 wires I talked earlier that wasn't being labeled. See, they all have color comments, so it should be simple to connect them to the hardware part. Okay.
I think we want to go on this more.
So this is about 500 lines of code on the Arduino. So to program this, just go to Tools on the menu and go to serial port, and make sure you pick the right serial port, mine 24, and it's going to show up on your device manager. So just pick that serial port and use tool. This is hard using this camera. Tools and do program. Where is the program? Alright, so sorry about that. So this is how you program. So this right here is the verify button. Just click it and it'll compile and check for any error. Or you can click upload, which will compile, check the error, and then it will automatically upload to the Arduino. So I'm going to click that. And over here should be a load button. A display that shows the progress. It takes about 20 seconds. If this doesn't work, it gets stuck at the upload time, just disconnect the USB cable and try again. It should work the second time.
And I think the way they
So once uploading, you know, because the LED will start flashing. It's still compiling.
Okay, versus.
But there's a T here.
Okay.
Oops.
That's to be 0.1.
Okay, so
Compiling sketch.
once that you're finding your bills,
Almost there.
and then just
Alright, it should work now.
yeah, it's just it takes me a
Okay, I think it got stuck again. So we might have to do this again.
I think this has the package for B-spline.
Sometimes it does that, so. Alright, we're gonna. Okay, so let's assume it didn't work. Or it takes too long. And you just unplug this, like this. And plug it back in. And go back to tool, serial port, check, see it's there, it's checked. And try again. Try to press the upload button again. Still waiting.
Okay, so I've got two B-spline running.
Alright. It's working. So see the LEDs are blinking and it's uploaded. And to confirm that, go to your program and it say done uploading, button sketch size, 12 kilobytes. So the maximum is 258 kilobytes of flash memory. So that's plenty of space, you don't have to worry about that. So now it's uploaded, you can debug it through this this USB wire, because the program is set so that it can be shared through the 0 lines. So let me show you what I'm talking about. Okay. So to debug on the command line, you just go to Tools, Serial Monitor, click on that, and it's going to pop a serial monitor here, like this. And notice how it's spitting out 3 numbers right now.
Right. I'm using
See that?
Eclipse, but I can
And it takes, I have a delay for where it takes 10 seconds for to let the XP warm up. And after 10 seconds, it should send out 3 messages. I'm alive 1, 2, and 3.
Well, there's a one called Bob.
And this is when you start when you can send commands to this to the robot and start responding. So the first command is the it follows like this. So if you notice on your keyboard, you have the exclamation mark, the @ sign, the pound, the dollar, the percent. Those are programmed in as commands for now. I have also programmed the asterisk for stopping robot, and over here the backslash, the forward slash is for accessing the 9 degrees of freedom sensor. The exclamation sign is for changing the tilt angle. @ is for the pen. Penning servo, of course, tilt servo, pen servo. And this is the pound, which is for the laser rangefinder. The dollar sign is for camera image capturing mode. The asterisk stopping robot, as I mentioned earlier. The forward slash plus a letter A for accelerometer, G for gyro, and C for compass. So, alright, so let's test it out. Let's test it out. Let's see what it looks like. So let's see, if I press, see that? And I want to go to 100 degree, just do that exclamation and follow 100. Press enter, and it should spit out a feedback. This is from the robot, of course. And it's tilting at an increment of 1 degree at a time, so that it won't have a jerking motion. See, tilting. Of course, right now I'm not powering up. If I flip the switch on, the servo will move to that position. So let's see what happens if I switch it on. See that? It moves to the 100 degree angle. So if now I press that, and then 110, and press enter, and I'll show you how the robot will respond. The servo will move forward to 100 degree, and this is a 270 degree, 180 degree servo. That's the maximum angle it can move. The lower, the pen servo, is 360. It's different from this type of servo, where it's controlled by a speed value, not by an angle value. So 90 is a stop, 95 is rotate clockwise, 85 is rotate it counterclockwise. The higher number, the bigger number, the bigger the difference between the angle and the 90, the faster it will turn to that direction. So, for example, 100 will turn faster than 95 to counterclockwise, and 80 will turn faster than 85 counterclockwise. Okay, so let's try to turn it. So this is the reason why in the code I have a time limit on the maximum duration of the pen servo will be active, which is half a second. So let's try and go to the clockwise at a speed of 95. So let's see what happens here.
So let's see if we print all the values instead of the read first. Plotting all the values.
There you go. So let's just press enter. Okay, now I want to go left, so I press 85, which is a normal speed I would probably use. Not too fast, not too slow. Sometimes you see the jerking motion. That's because the battery could be low, or B, it's just the power consumption is fluctuating, and it's not enough power to compensate for the DC-DC step-down converter. which will cause the jerking motion on the servo, which will ultimately affect the 9-degree freedom sensor, which is sensitive to motion, of course.
Let's write a text file so we can see what all those
Okay, so now that we know, so you notice here, whenever the robot does something, it will send you a message to confirm what you enter and what it's doing. So let's do this command. This command requires only the pound sign to take to access. When you send this command, the robot will activate. It will activate the laser rangefinder, and it will send you back a distant measurement from the rangefinder. This one. So I press enter with the pound sign.
So we got two. This is the clicking one. That's the one you saw right there. So this one. So instead of working with
well, it's let's try to. Oh wait, I forgot. Okay, this is a good lesson. Right now it's a be patient and it's in a loop right now. You know why? Because the XB is powering up the breadboard and it's not been connected right now, right? Because we're out of programming mode, we must reconnect these two wires, the ground and the 5 volts. These two wires back in so we can feed the breadboard for the to power up this thing. This thing is not powered right now. So just make sure you put this back after programming mode, okay? And the USB too, of course. Okay. All right. Let me pause this and then I'll go back. All right. Before I begin, continue with this video, instead of using the USB cable, I'm gonna start using the XB to send wireless commands to the robot for now. So just hook it up, and then go to Tools, and then pick your serial port. It's 26 for mine, and use the serial monitor. Open it up, and after you do that, turn on the robot, and make sure all the wires hooked up. Alright, so this is wireless right now. Alright. So after you see the I'm alive status, you know robot's ready to go. So now we can use our laser rangefinder. Press the pound sign and press enter. And you notice it can output the distant. Well, let's try that again. This thing is pointing at a really long range distance, so it's not gonna work as well when the maximum is 1.5 meters. That's a reliable measurement anyways. So you might want to turn the laser rangefinder toward an object that's closer. So I'm using the pen command. And then I'm going to turn it left. What? Alright, so now you can use the pound sign to take measurement. Okay, press enter. And then it's going to output the distance. It's 401 millimeter, which is 0.4 meters. Alright, let's see that work. Now you want to take a picture. Just press the $sign.
Anyway, I thought I'd kind of harass you about that.
And then press enter.
Well, this is the glass thing that I was
Yeah.
See what I'm saying?
Yeah,
So then I grab a
no.
little bit. Sometimes you get better in here.
It's stuck my wire.
Are you getting some bids?
I just get one just to see what it is relative.
Oh, yeah.
It doesn't have to go all the way. In fact, if it just goes here, that's fine.
Sure. Okay.
Plexiglass?
So
It's cheaper.
I press enter.
Just,
You take a picture. And turn on.
See that? I built that over there. Did you really? Yeah, see? That's creative. Yeah.
Turn on off the flash.
You take the sand and melt it and I melted the glass.
Take a picture again. So use a $sign.
Yeah. I'll tell you what the worst
And press enter and it takes the picture. So it's going to show you the feedback here. So that it's done. Okay.
Do that. That's okay. No.
And for the driving mode,
Oh yeah.
you use the % sign like that, and next to it press 8 for going forward. It's pretty much intuitive here. So 8 is forward, 4 is left, 2 is backwards, 6 is turn right, and then this is the stop. Okay, so for example, let me turn off the power so it doesn't move. But then my wireless won't work, so that's not going to work. Alright, so which means I have to switch to
now you know what I'm jealous now. I mean, you got a portrait studio, you got remote control cars, and you got we do all the stuff that nobody else wants to do. Like, yeah, because I tried going down to Norman and said, let's do this, I don't want to do it. But actually, I'm building that to map out. It's like that. It's going to map out. It's doing mapping of
okay, switch back to wire. So we're going to show you guys on the command line.
Like the Google map. So will it oh really? It's taking like you click and look and all that. So that's my little, I mean you operate it really. I'm going to make it autonomous. Really? So it like uses lens to project? Yeah, like see, we do cool stuff. Yeah.
See,
alright, I'll let you get back to work.
It's going to send you a feedback.
Oh yeah, it's going to be Dr. Campbell, so.
Invalid command.
Yeah. Okay. Anyway, see you later. See you later, thanks. Okay, so let's go. Alright, anyway, so this is just
Okay, so I figured why it didn't work last time, because when we go back to wire, it's probably best to unplug the XB and the wires back here, because there's when you have the XB on, it's gonna mess up the grounding, because you have the laptop and then you get the battery, and then if the grounding is not right, then the serial communication is not gonna work just right. So it's just best to unplug that XB and then just debugging just using the USB wire. So if you want to go backward, just %2, press enter, and it's going to send you a message on back, let you know it's going backward. And you want to go to the right, press %6, and let's say right. Same thing for the left. And then if you want to stop, press the asterisk, press enter, and it's gonna stop it. See? Okay, now next, if you want to take a measurement from the sensor, /A for acceleration, and then you can see the acceleration readings. It's 3-axis. So, and then you want to see the gyro, %G, /G, and you see the gyro here, and same thing, but just using /C for compass, and you see the compass reading. It's a magnetic, so it's mag. Okay, and that's all there is to it, using the command line to control a robot. Alright. Just be careful if the robot gets jerky, or it moves it moves when it's not supposed to, and have your finger ready on the power supply to turn it off. Okay. Okay. Let's have a quick look over the program. So in the program, the first part has to do with the I2C and the 9° of freedom sensor, and you start seeing a bunch of registers. And this program is written by someone else. Took off online, so just save a lot of time. You just use their program to access the 9° freedom sensor. And then here's where the code I wrote. So this is where I define all the pin numbers, as you can see. And then you can set the threshold for the minimum and maximum angle for tilt, and pen minimum maximum speed, rotation speed. And then you have the angle 0, which is the initial angle for the tilt, and the speed, initial speed for the pen. Get the LD for debugging, XP delay time of 10 seconds. The motor power is for the MOSFET, servo power for MOSFET. Pin number, and then and you see the comments next to it. So logic power is the grounding for the logic side of the motor driver. The tilt servo pin is the pulse width modulation pin number 2. Pen servo pin is similar, that's number 3. Alright, so
I was thinking we could have that because we were needing to use it for some further couple, so we have that R lab each here.
alright, let's keep going.
I'm actually like right across the street from
So next is the function I made for the laser rangefinder. It just it just wait for the basically it's a serial communication protocol to accept the feedback from the laser rangefinder when you first jump start the laser rangefinder. Alright, the next function is the void, the stop pen is for the servo. So basically it's a timer based function. So it's gonna stop the servo from spinning after 500 milliseconds. Well, this depends on the input time, but it's going to be 500 milliseconds.
Alright, thank you.
So it's not too important here. And then the following code here, down all the way to this part here, is the code that I got online where they wrote. It's made for. It's basically a firmware written for the. For the 9° of freedom sensor. So it's not really important if you want to skip it, but just some register manipulation and all that stuff. And here is the setup function. It's this label setup function, and this is where you initialize the serial ports you want to use, and then the baud rate you want to use. Serial 1, this is serial 0 by the way, so begin, serial 1, begin. We only use 2 serial lines. This one is for the laser rangefinder, and this one is for the XB and communicate with the computer. Wire begin is for the I2C init. And then next part we clear the memory space inside the array for three arrays that store the sensors reading, the accelerometer data, the compass, and the gyro. The compass is also called a magnetic sensor. Okay, the next part is the three lines of code that initialize the sensors within the 9° freedom sensor. And then the next thing we do is we basically initialize the servos. That's where you have my servo 1 attached, and then tilt servo pin is the pin number we're defined to be, so it's going to be like 2 and 3. And here I have this is like initialized to the initial angle 90 plus 8. This is to compensate for the initial jerk that it has. You can change to whatever you want here. This is a configuration setting. Alright, okay. Next we have this part is where we set the digital pin to output mode, basically using the pin mode function, and then the pin number and it's set to output. And here we have the digital write. This is where we turn on the power to servos, motors, and the logic gates. The reason why this is these are high because we need to turn on the gate high to activate the MOSFET, so it's gonna connect to ground. But then the motor logic power, since there's not that much current being used, so the Arduino can sink a small amount of current. It's like 100 milliamps maximum or something. So I just use as a sink instead, just to simplify the circuit. So I just made it low to sink the current. The next part is where we configure the polarity and the on-off state of the motors. So we can do that by changing the logic on the small signal side of the motor driver. So we have the pins here and then high or low. It just happened that the motors are set up so that when it's like this, it will move forward when the control are both high. If you have this thing low, it's gonna spin. So these can change, but this is how I have the robot set up so that I move forward when these two are on high at the same time. These are the LD pins. So I send both of them are to output, but one is a positive and the other is negative, or anode and cathode. Then the next is the camera part, where you have okay, this is where I have the camera pin. This is where you keep it low so that the camera is so that the MOSFET is open circuit. When the digital write, this thing is heavy, so this camera. So let me check. Okay.
So now the question.
Okay, servo right angle 0. What the heck? I think there's a bug. Servo 2. Okay, that's why it's been spinning. Oh, yeah, never mind. And this is when we stop the servo from spinning. Earlier we have the adjustment. It's about 8 degrees. Right here, and down here is where we have it stop from spinning. Okay, and we have the LD blink just after the XP delay, and it's going to send out the status when it's done setting up, and it's going back to the loop. This is where it start waiting for a user to send commands. So it's accepting commands. So this part is where it's going to flush its buffers. The 0 and 1 clear buffer, and it's going to create an array to